All right, we're back at it again with Piplash. So this is a 6 pound combat robot. It has the general form factor of Whiplash. So prior we set up the drive pods and just kind of waiting on the wheels for getting that portion complete. But today we're going to actually work on the weapon assembly, the arm assembly itself. So I'm going to start by putting together the weapon assembly into the spinner portion of it into the arms and get the arm put together. And then I'm going to swap over and then put in the gearbox for the actual lifter mechanism. So with the arms, I have the UHMW side rails, and I'm not sure what order of operations I'm going to take here. I'm thinking weapon first. I think I'll put the weapon on, drop in the standoffs for the gear, and then we'll just kind of sandwich it together. And then after that, we'll pull out the actual lifter base section of it that holds that. We'll put in the gear for that and then reinstall a little bit in the robot. So within these, I have these bushings in the back, and then those ride along a shoulder shaft or a shoulder bolt, and that's how we keep this from all binding up. So I'm gonna press in I got one pressed in already, so we're gonna get the other one going. So they're pretty snug fit, but I got the other one in just by pressing it against the table. There we go. So that's seated in nice and easy. That's going to come out a lot harder, but for now, I'm not too worried about that. I think I want to put the shoulder bolts and the weapon in first. I'm going to do the shoulder bolt first. So there's a bit of a shoulder in there as well, so they slot in, the key in. And so there's 3 of these that go into there. Install those first. That way I don't have to worry about the wires on the motor as much when I'm messing around with that. Oh, I did that wrong because there's an additional piece that goes in here. There's these little guys. Almost forgot them. So on the CAD model that's out there currently, it doesn't have these little tabs on it. I added those on there because there was no other way for this to retain. It would just free spin by itself, and I didn't much care for that. So I'm gonna upload those eventually here. There's a couple other changes as well. The hole for the weapon mount, this one up front through the shaft, was undersized as well. So I had to adjust that manually. I actually boogered this one up when I did it. So it's a little bit wallowed out, but the screws will hold it in place, and it really only has to make it through one match for now. So I'm not going to worry about it this time around. Next time I'll cut some fresh ones and we'll get it right. But there's some other additions I want to do on the arm, so I kind of just want to wait and see first how things go, and then I'll adjust from there. No need to throw out a part though when it's going to do the job it needs to. All right, so that's the standoffs in, right? So we have the TPU printed cover, the UHMW side, and then those number 6 screws I put in just go straight into these. That one's a little loose. There we go, that's better. Make sure they're all nice and tight. And then I can't help myself, I gotta put this gear on. It's just too pretty to not be on there. So the gear itself is also TPU. I'm gonna stab my hand with this. I might have got my order of operations wrong there. Might have been easier to go the other way. I do, however, have an arbor press handy, so let's use the right tool for the job. Much easier. Boogered up the end of that one, but that'll be fine. And then this little section here is a wire channel to let the wires go down. It looks like it's, oh, you know what? I put it on the wrong way. It's supposed to go the other way. I don't like the idea of pulling that back off. I think those standoffs live there now. I'm gonna take the simpler route and just swap out the screws and just flip the whole assembly. We'll take the path of least resistance. All right, so this is supposed to go this way. There we go. That was easy enough. So the wires will eventually route down through there. I'm not going to solder it up for a little while yet, so not going to bother with that. Just yet again, just test fitting things. Get these guys back in place. I am a little worried about the inside of this print. Looks like it's flush with the bushing, so it might rub a little bit. I might have to reprint that or drill it out. Drilling out TPU is not exactly fun at that diameter, though. It wants to be really grippy with the bit. It might not actually cut. It might just rub. So I'll have to see what I'll have to do there. We'll find out in a few minutes whether or not it works. All right, so that's on. So now I want to get the motor in place. So I got to be careful with this wire because there are solder joints just underneath that heat shrink. So I want to make sure I'm ultra careful putting that in. I think I want to drop the shoulder screw through first just to get my general placement. And then I'll drop the weapon in the actual blade right after this, because I think I can do that without too much struggle. I think my screws might be short. Oh, my screws are super short. Thought I had long enough ones. Yeah, I don't know what happened there. I'll have to grab some longer ones. I'll be right back. Looks like one of my kids got into the screw bin and did some resorting. All right. So these are M4 by 16 is what I grabbed. They could probably go for being a little bit longer. Maybe an 18 would fit better. They're mostly just to stop the can from trying to rotate the stator of the motor from rotating. So we got that. Looks like we got enough cable, enough wire here to route as well. And then as I spoke with DJ before, for now we're just going to hold these wires in place with some hot glue. In the future, I think I'm going to put a little plate in there. All right, so now I can put on the weapon blade. And so it could fit on in either direction, but you're going to want it going upwards for the robot. So the blade should be spinning upwards, right? The idea being that you hit your opponent towards the roof. That way you backstop against the floor. So this is just some AR 500 from Suncut Send. And then it's painted with some Montana Gold spray paint. I think the color is called Light Poison, if I recall correctly. And then I don't plan on taking the weapon back off, so I'm going to Loctite this guy in place right now. So just a little dab of blue Loctite. And then I'm going to wait until I have all the screws in to tighten down because I don't want the blade getting off center. Side to side, that is. I don't want it to wobble. I had to do a little bit of touch-up work on the blades. They were that's not fitting very well. There were some burrs on the inside. These are all cut with fiber lasers, and the fiber laser had left some artifacts on the inside that had to be taken care of. I don't know if it's just that screw, but that didn't want to go into either one of those two sides of the hub. It could also be the hub. those threads just felt wrong. The first one felt fine. We'll try a different screw and yeah, they're just kind of tight. It's issue with the threads again. The threads are just kind of boogered on this side, it seems. They're not well formed. There it goes. And I gotta be careful on touching the paint with Loctite on my hands because the this specific paint with Loctite doesn't play very well. It it'll take it off. Yeah, just a little tight on this side for some reason. The threads just aren't like fully formed at first, or there's some debris in there. All right, now that I got them all in, just gonna kind of start patterning them to make sure it sits down nice and flush. So I believe it's a 4.5 inch disc. I didn't get a weight on it yet. I got another blank one. I'll measure and see what it ended up weighing. This would be a small disc even at a beetle weight scale, let alone a 6 pound scale. The primary weapon in this case is the lifter arm. The lifter arm is the important part. Everything else is um, kind of secondary here. And then with these repeat hubs, you need this little washer on the far side to stop it from essentially pulling apart the hub. And then I don't have the nut on this side yet. I don't have one sitting down here, and I'm not going to go search for one. But okay, so there's the basic arm assembly. Get the other side attached here real quick. Oh, I had yeah, there we go. That'll be faster. Trying to make sure I have things staged out a little bit more. I keep these videos moving since I'm not editing. Like I said, I am worried about the 3D print in there grabbing the shoulder bolt as I install it, so we'll see how the fit is on that. It might need to be adjusted. All right, so that's an arm assembly done. Those wires actually look long enough. That might actually work without having to add a small segment to them. So everything looks reasonable there. I want to find a way in the future to lock these together with a piece of metal if I need to, or even a standoff in here. You know, one that's just outside of the blade range to ensure that they don't get separated. So I'm gonna set that to the side, and then we're gonna start working on the center section. So I already loosened everything up here yet again, trying to save some time on these. So this piece is already loose. So that to the side as well. All right, so now I have to set up the motor. So these high reduction gearboxes don't come with the pinion pushed on or the motor all set up. So I'm gonna do that right now. I'm gonna press on the pinion. So yet again with the arbor press, and then I'm gonna use one of the front pieces of armor. So this is the same metal shipment I got from Senkatsen. So this is 3mm AR 500. These are the plates I'd run against like drums and verts for the most part. Specifically drums and beater bars. I'd run this, and then I did weld up one of the front wedgelets, and then this is what would be against like an undercutter or any sort of horizontal. I would run these. Not sure what I'd run against the control bot. I'd probably try to get some sort of fork in there. But I'm gonna use one of the plates to act as a backstop for pressing on the pinion. Sure the camera angle can see it. So key here is it should go on relatively easily. Just got to make sure it's nice and centered. And then I'm rotating the can just in case there's any sort of angle in my assembly. So I'm just pressing down a little bit and then rotating the can. I want to make sure that that gear goes on nice and smooth until it's flush. And then the back of the shaft is flush with the back. So that's what's pressing against this plate to make sure it's not shoving the whole assembly through the robot or through the motor here. Because otherwise, if you press on that shaft, you can bend some of the internals, and then your motor won't freely turn. But the motor still freely turns, so no problem there. It's nice and flush on the end, so that should be good to go. All right, so now I have the plate for the gearbox. So this is the mounting plate for the motor. And then I don't believe anything here is particularly directional. Looks like the motor comes off at a slight angle. I just want to make sure my wires are lined up in a way where they're, um, I guess I don't really have a choice. They kind of go in one way and that's about it. Just wanted to make sure the wires are going to be able to exit the frame without getting bound up. So yet again, I don't plan on pulling this assembly open again, so I'm gonna put some Loctite on these. And that's just blue Loctite, just run of the mill, standard stuff here. This is an M3 by 6 button head screw. You don't want the screws too long for these because if they get too long, they'll get into the coils of the motor, and that will cause the motor to go up in flames. It'll burn off the enamel because it'll short it. Ooh. I'm excited to get this thing together. It should be fun. I got a chance to see it with the wedgelets on. I couldn't help myself when I did some mock assembly, and it looked pretty decent, so I'm excited. It's probably only going to get one match, maybe two matches on its debut because there's just not that many opponents right now. There's one confirmed opponent with Ben, and he's got a big, giant, wide vert. So we'll see how it goes with that. We'll see if this thing can take a hit, because Ben is no slouch. He's the builder of Blight, which is a top-notch ant weight. But he doesn't have much experience in the larger weight classes, so we'll see if I can pull one over on him there. All right, so just kind of snugging down all of these. And I said this in a prior video, but these gearboxes, you can buy just the high reduction gearbox. It doesn't come with a motor assembly on it, and then you buy essentially the spare drive motor. This would be a drive motor for like a 12-pounder. Um, the only thing that it didn't come with, so it came with the pinion and all of that. The only thing it didn't come with um, was the M6 screws to actually mount the thing, which seems like a bit of a failing. I would like to see that on there personally. So there's a little plate here that stops the planetary gears from rubbing against the inner shaft. And then this is as far as I'm going to take this part for right now, because it actually bolts through using the same bolts there. So I got to get that ready. And then with that, there's these two spacer plates that help dampen it and take up the extra room. So these have to go on next. So I'm just going to kind of thread that through. I'm going to push it on the can first and then feed the bolts through. There's a lot of little tiny pieces inside of this gearbox, and it's all kind of hanging loose right now, so I got to be ultra careful to not spill out the contents. It'd be fine if I do, but it'd just be kind of annoying. Oh, and then I put that on backwards, so now I got to do it again. There's there's two independent pieces. One has this little recession on the top. It's probably hard to see that. It's a little notch on the top, and that's for clearance on the arm, and that's got to go to the outside. And then we'll see if I can feed this plate through without disassembling that other segment. I might be able to do it, I'm not sure. Oh, it's really close. I think I can wedge it through there. I think it'll work. See if the hole on the other side is big enough. I think the sticker is going to cause me trouble on the gearbox. That's a Yeah, the sticker is going to cause trouble. That's how tight the clearance is. It's ripping the sticker off as I push it through. There we go. Some of the stickers stayed intact. We could probably adjust that to make that a little bit bigger. And then it looks like there's a tall side on this. I think the tall side goes to the bottom. All right, so that's in place. And then these gearboxes have to be lubricated before they're used. So I'm going to grab some grease real quick. Well, I didn't have any grease that was easily reachable, but I did find some of the oil that I used to lubricate the CNC machine with. I'll plan on rebuilding all this anyways after the first time it goes out. So I'll just lube it with a little bit of oil for now, and then it'll get rebuilt afterwards. I want to tear it apart to ensure that everything is still correctly seated. And now trying to put the motor plate back on. Although that feels, oh, that's annoying. It's directional. Can I rotate this part? No, because it's stuck with the, so there's a keying feature that lines up with a little keying feature in here. And I don't think the front is keyed. I gotta be careful not to knock the gears out of this thing. But I gotta try and turn that. And the trouble is that sticker is causing trouble again. I could have planned this out a little bit better. There we go. And then I think I'm gonna have to take off the side anyways now, because I need to get at the screws internally. It's gonna be easier if that whole drive side is off, or the inner rail is off. So I'll pull the couple of screws out of there. Get that disconnected so that I can get this guy together properly. Okay. That is a little bit on the futzy side. That one's too big. And I want to make sure that faceplate is fully seated before I get too far, because I don't want to slam the internal gears in if they're not quite in place. And then I'm not going to tighten it down all the way yet. Ideally, there would have been a bit of Loctite put on that back plate, but I'm going to ignore it for now. I'll get it later. It's only going to go through, like I said, 1 or 2 fights before I open it all back up and service it anyways. So I'm not too worried. It'll hold up for a fight, that's for sure. All right. It looks a bit loose in terms of the spacing here. Like it's not quite. Yeah, there's a bit of play. I think it'll be fine for now, but we'll increase the size of the spacers so they take up all that space. Like I said, for now, it's sliding around. That eighth of an inch is not going to hurt anything for the limited run that it's going to do. And that's what happens, right? When parts get they change manufacturers, they change subtle design changes, and CAD models and things like that don't get updated. So there's just a bit of a gap there, but that'll be okay. Set those screws to the side. Now it's time to put on the gear to drive the arm with. So there's a little bit of extra reduction there. So I have these tiny little carbon fiber plates that, since they're rigid, they'll help on this hex shaft from the TPU just kind of free spinning around the shaft. So those go in with a set of number 2 screws. So tiny, tiny, tiny little screws, itty bitty little guys. Let's see if I got the right size of head for those currently. And it looks like I do not, so I gotta run up again. Or do I right here? No, I do not. I will be right back again. All right, so tiny little screwdriver, number 6 Torx. So there's 3 little flathead screws per side. And then the only thing that holds this together from it coming off currently is just friction. So I'm not super big fan of that. I might want to get a shaft collar on there. So there are those. Now for the other side. And then 3 more little screws. Yeah, it was a fun little part to cut. It was very, very small. So the work holding was interesting. And I didn't have a lot of faith that they would cut correctly, so I cut like 6 of them out just in case one came loose, and I ended up getting all of them. So those are installed, nice and tiny. Press that on now. Yeah, it's a little more loose than I'd like. I think it'll stay put, I think, but I'd like if that was a little bit tighter. Just a little bit too easy to pull it off. But all right, so next up, reinstall the side. Three screws, 3 plastite screws going back in. And then now we can drop in the weapon assembly. So now that this guy is done, we'll see how bad pressing that through is going to be. Oh, not bad. Not bad at all. There we go. All right, so now if we turn the motor, we should start to see the arm lift. It's pretty well sprung. I can feel how springy it's feeling right now. It's wanting to turn back on me. Oh, that's not going to work. So, oh, you know what? I might have been spinning it down so that it was pressing against it might have been pressing against the frame. All right. So this way I should have left. Yep, that's what I was doing. I was pressing it into the frame and then it flexed away when it got all the way down, which actually might be a good feature because that'll prevent the motor from burning out. But so there we can see the all the gear reduction at work to lift that arm. And then so this has a pretty good full range of motion. And so there's there's enough play in the system, and it's a low enough gear ratio where this will continue. You'll have to hold it in either direction. So the lifting action, it won't be able to just stop at a point. The gear reduction's small enough. You have to get up in the like 300 plus to 1 ratio before um, before they start to stay put. And anything in like the 600-700 range, something up in that area, will it'll hold its position. Because otherwise you'll just back drive it like what it's doing currently. But that's a good sign because that means it's all loose enough um, where everything's turning freely. So now I'm going to reinstall this back into the frame, into the chassis. So I got to just kind of line that up, make sure the wires are out of the way. Oh, and then tuck it back in. There we go. So that's seated in pretty nicely. And then I'm going to go after the back screws first. Going to get 2 of them in place, and then I'm going to do a set of the front screws. Okay. And then ideally I'll build a stand, right, to stop that from happening. Because it's resting on the weapon. So it's wanting to rotate when it's upside down. And it's going to have to be worked on like this in some occasions. So having a stand to help with that will be nice. So there's quite a bit of screws to get the weapon assembly out. So I'm a little bit worried about that in terms of like serviceability. So there's the 6 screws on the bottom. There's 6 screws in the back. And then there's 4 screws that go through the front armor mounting plate. But then also the armor has to come off of that front, and that whole plate has to come out. So it's actually 4 screws per plate plus an additional 2 screws for the armor. And then you got the top screws that have to be removed to efficiently get the plates out. So it's a lot of screws to pull the weapon assembly. So I'm slightly worried in the future when having to do it under pressure and under a time restraint, right, that it could become a problem. So then this is the front plate that mounts the armor on. I cut this out in my own shop. I boogered up the second one. I was tapping it and I broke a tap off, and it really needed to get a tapping arm. So I have to remake that plate. I'm not going to bother trying to pull the tap out. It'll be faster just to make another plate. But so it's got 2 quarter 20 taps on the inside, and then through holes for the plastite screws. So I'm going to install one of those real quick. So this one's a bit of a tighter fit. Yeah, it didn't seem too bad. I thought it was worse than that the first time. And then it's got 3/4 inch plastite screws holding it to the UHMW frame. All right, so now that front piece is on. And then let's throw on the wedge. So for the wedge, they're directional, so they have a side that slants down, and then underneath there's a little support on the side, and then this is a separate piece. So I welded up all of this last night and then ground it all flat and painted it. And then there's a little backer plate that's made out of TPU that goes behind it to help dampen it. Slightly worried about the mounting on that, but we'll see how it goes. A little bit of weld spatter in the holes right now too, so they're not as clean as they could be. Because there is a welded joint right underneath these holes. I should have cleared them back out with the drill press, but I opted to not. So I'm gonna line that up. And then that little pad also helps it gives a distance off of the screws that went into the frame so that those don't have to be flathead. And then, so it's a 1/4 20 button head screw to hold these on. It's 9/16 of an inch long. And so it's just enough distance where it just butts up against the inner guard. All right, so that's in there. And then I did get the batteries the other day. So the battery that we're trying out with it is a 6S 1000 milliamp hour battery. It's yet to be determined whether or not that'll be adequate, but we'll find out. We're only intending on doing 2-minute matches with these instead of a 3-minute. So best guess is it's probably more than enough. But we'll find out. Tuck those wires into there. And then the battery, I'm thinking I'm going to place it with the wires going towards the front, and then I'm going to bend this wire back around. So when I mount in the power, essentially you'll just set the battery in like this, plug it in, and then tuck the wire in on the side is the way I'm thinking. So just like that. And then top plate with the screw. I really think on these two, I think I want to center up the power switch. It's kind of hard because it interferes with where the wires come out. But if I center that up, I could put the hole on both sides. That way you can flip the panels and then use them on both sides. Just easier service, essentially, is what I'm aiming for. And then number 6 by 3/8 inch long plastites for the top panel here. Been quite a few people that have downloaded the CAD for this, so I hope they're getting some value out of it. Currently, there's all the flaws are still in that CAD, so be careful if you are one of the people who are attempting to build one of these. There is issues. Over time, I'll remedy those, but for right now, I'm not too worried about it. I got event prep to do next weekend for next week, so it's that's going to take priority over this. So 4 screws per panel for the plastites, and then 4 number 6 screws to hold in those inner retainers that have the standoffs in them. And then I said it before, but it's worth reiterating because the screws look really, really similar. Um, be sure not to try to thread a plastite into one of the standoffs. It will damage the threads. They are a different thread type. I'm thinking about painting my non-plastite screws so that I don't make that mistake myself. Just the heads of them, that way I can see which ones are which. And then a lot of times what I'll do is inside the robot or on some of the segments, I'll actually write down with a paint marker what screws go where. And then same thing with the wiring. If you crack open any of my bots that I've used for a while, I have wiring diagrams underneath the top panel so that so I don't have to remember. It's one of those like useful tips where like you think you'll remember, but you never do. I don't trust my own memory, so that is that. Kind of get a sneak peek of what it's looking like now, and then the additional armor plates for like the for vertical spinners and our drums or beaters, right? So starting to look like a robot. That's feeling tight. I'm not sure what's going on. I wonder if something's rubbing on that motor on the inside, because that's feeling tighter than what it was before. It could also be if the motor leads, because they're bare right now. It could be that they're touching each other, or they're touching the base panels. Carbon fiber is conductive, so it will short out a robot if you have the wire sitting against it. And if those leads are touching each other inside, they they'll actually cause the motor to, oh, I pinched the wires in there too, but they'll cause the motor to be a heck of a lot slower. So, but yeah, I pinched the wires in when I was assembling, so let's fix that real quick. There we go. I think the internal wire guard probably needs to be reprinted so that the wires come through at a more ideal location. Currently, it's not. There's a hole for them, but it's not ideal. It needs to be on the back side of it. And then the other thing I was looking at too is when this weapons assembly comes out, I'm planning on putting the electronics underneath that panel, or at least a good chunk of them underneath that panel. And I want something to hold them in place so that when that panel comes off, when the top of the robot comes off, I want those to stay right where they're at to make sure that the robot is serviceable. Yeah, you can see the arm is coming down a lot slower now. So I'm guessing it's still spinning, but I'm guessing the wire ends are touching, which is causing it to not fully release. And then I did print out the wheels, the blanks for the hubs, as well as the wheel molds. So it's a two-part mold. It's just a cap to keep the wheel down, and then on the inside there's a keying feature for the wheel to keep it. Once it kind of clicks in, it keeps it centered. So I'll cast those probably next, and then after that we'll move on to some of the final touches like the wiring, getting all that in there, give it a test drive, and make sure it all works for next weekend. But for now, that'll be it. Thank you.